All right, so here is the next video. So to get us prepared for our lesson on Tuesday of next week, partial decomposition of fractions, I thought we should just kind of review basic fraction knowledge, right? So you're looking at the first four examples. And again, these are examples where I don't think necessarily you need to copy them down. So you just pay attention, right? So a couple different ones, right? Some adding, some subtracting. So whenever you're adding fractions or you're subtracting fractions, they need to have what? Right, a common denominator. Right? If they don't have a common denominator, you need to get one, right? Lowest common denominator. Right? So if I look at, example 1, I see that the denominators are both 7, right? So 4 plus 1 gives us 5 over 7. There's no way to reduce that fraction, so we're fine, right? If I look at example 2, right, again, subtraction, same denominator, 24, so 13 minus 10 gives you 3 over 24. This one can be reduced, right? 3 and goes into 24 8 times, so 1 over 8, right? Please make sure that you pay attention to that. Common mistake for example 2 would just be saying the answer is 8. So just FYI, be careful. It doesn't matter if it has variables in the denominator or it has integers in the denominator, right? So both of the denominators are x's. They're exactly the same. So 1 plus 2 gives you 3 over x. No way to reduce that. Again, notice that we have a binomial. Now, binomials are tricky, right? You want to make sure that with binomials that you have everything the same. So if you have something that's a monomial like x, and then you have a binomial as x plus 2, they're not the same. So you'd have to have them have the same denominator, which we'll get to, right? So same denominator, then we're just going to subtract the numerators together. So x minus 1 can't be simplified. So you leave it alone as x minus 1 on the top and x plus 2 on the bottom. Please also note that whenever you see an addition or subtraction sign, these problems, they come together. So there's no way that I'm going to eliminate the x's from both the numerator and denominator. So I like to call it like a package, right? So I always like to put it around parentheses. So if the binomials are the same, then I can eliminate the binomials. But if there's only a part of the binomial that's the same, I cannot eliminate it. So I want to think about it that way. Okay. Looking at example 5 and 6. So again, very simple example. 3 and 2, there's no way to add these together without changing the denominator. So this one's missing the 2. So 2 over 2. So this will be 2 over 6. This is missing a 3. So multiply 3 over 1. Again, I'm stating things that you should already know and be aware of, right? You multiply any number by 1, it's not changing the value of it, right? So plus 3 over 6, add them together, you get 5 over 6, right? Which is our answer. And again, doesn't matter if it's variables or numbers, right? This one's missing the y, so y over y, so y over xy, and over here, missing the x, x. And again, they're the same denominator now. And it's okay if you accidentally switch them up, xy and yx. Doesn't really make a difference. But how we add them together does. So the y is coming first, so you want to make sure that the y stays in the front. Okay? So these are just basic fractions, which I think most people will be perfectly fine together with, right? So now I want to come to some other harder examples, right, of adding fractions together. So this is where a common mistake is they're like, most students say, oh, they have an x in common, so I just need to make this become a plus 1. Well, if I multiply the top and bottom by a 1, this will still be a 1x. So there's no way to add a plus 1 into the denominator. So these are two separate denominators. So this has an x. Again, think of this as an x plus 1. So this one is missing an x plus 1. So again, I'm multiplying both the top and bottom by an x plus 1. This one's missing the x. So multiply the top and bottom. So distribute 7x plus 7 all over x and x plus 1. Again, if you'd like to distribute the x out, that's fine. I usually wait to the end just in case there is anything I can't actually eliminate. And x plus 1 times x. So again, notice that I wrote the denominators a little bit different, but you know that they are the same. We're adding the fractions together, so 7x plus 7. Add that with just an x. There's only one term on this one, so don't have to worry about distributing anything. Collect your like terms, so 7x plus x gives us 8x plus 7, and an x plus 1, right? Again, we want to see if we can simplify our fraction. In the numerator, there's no number I can pull out, right, that they have in common. There's no variable I can pull out, so this is our answer. Here's our next problem, right? Subtraction. Again, a little bit harder. Just noticing, again, denominators are different. There's no way to make a -2 become a +3 or vice versa. So we do exactly what we did on this problem right here, where we multiply the top and bottom. So this time, this one's going to be multiplied by x minus 2 and x minus 2. This side will be x plus 3, x plus 3. So distribute, so x plus 3. Oops. There we go. X. Technical difficulties. I ran out of lead. Hold on. Okay. Better. Okay. Then x plus 3, x minus 2. Again, I'm not going to distribute it yet. Minus, and 1 times all of this, so that would be x minus 2, and then x plus 3, and x minus 2. Same denominator. Now be careful with the subtraction, right? Make a note right here. You should be at least copying down these last two examples. I don't mind if the first 3 or 4 you didn't, but for sure example 7 and example 8 should be copied down into your notebooks. So with subtraction, right, make sure that we really do put parentheses around, so that way you know to distribute, because the common mistake is keeping that to negative when in reality it should be positive, right? So there's nothing to distribute on over there, so this will become x plus 3, distribute minus x, distribute plus 2, and then becomes x plus 3 and x minus 2. The x's are going to cancel out, so 3 plus 2 gives you 5, and then x plus 3, x minus 2. At this point, you're going to hear me say this a lot throughout the school year. If you have the right answer, right, leave it alone, okay? There is no need that I feel that you need to distribute, okay? If I ask you to distribute, great, but most of the time I'm not going to, because you already have the right answer. What happens if you make a mistake by multiplying these two binomials together? Then your question is wrong, okay? Obviously, simplifying fractions, I do want you to do that, but there's nothing to simplify. The 5 doesn't go into anything, so we can call it the answer. But for sake of argument, let's distribute. So x times x gives you x squared. 3x minus 2x is just an x, and then a minus 6, right? So either one of these answers is perfectly fine. Okay, and excuse me, this last example is a very good example of what we're going to do on Tuesday. On Tuesday, you're going to be given this answer, okay? And decomposition means you're going to break up the problem into the original fractions, right? So we need to know how fractions work and things like that. So in reality, you'll be going from this all the way to what we started off with, right? But in order to get there, let's do a little extra practice. Let's start here and get there, okay? Hopefully that makes sense. If it doesn't make sense, I'll clarify it hopefully on Tuesday, okay? So adding fractions, subtracting fractions, you don't have to worry about multiplying. I mean, you just multiply straight across. You're not going to be doing any problems with division yet, okay? But what else can we do with these lovely fractions is we can solve. So notice that, again, we're using our knowledge of fractions in order to figure out what x can be. X can be any number, right? It's not in the denominator, so we have no restrictions. So you can either have them become the same denominator and then add them together, or you can multiply by your lowest common denominator just to cancel them all out. So I noticed that my lowest common denominator that will have both a 3 and a 4 would be 12. So I can just multiply everything by 12. So this will become 12x over 3, and then 36x over 4 is equal to 24. Right? So the 3 and the 12 will cancel out, leaving you with a 4x. And then 4 goes into 36 9 times. So 24. Add those together. We get 13x is equal to 24. So x is equal to 24 over 13. And we get our answer. Okay. It is important to check our work to make sure, especially with these longer problems that you're going to be seeing, we want to make sure that our answer makes sense, okay? Yes, you will get answers that have fractions in it, okay? So let's check our work. So everywhere I see an x, I'm going to put a 24 over 3, so 13, I should say. So 24 over 13 divided by 3 plus 3 times 24 over 13. Divide that by 4 is equal to 2. Now the great thing is I don't have to touch that side. I'm going to rewrite these problems because I don't like fraction over numbers. So it'll become 24 over 13 and then times 1/3. And then this will become 3, you can think of it as 3 over 1 times 24 over 13. And then multiply that by a 4th. And we're equal to 2. Okay. 3 goes into 24 8 times, right? So 8 over 13. And then 4 goes into 24 6 times. So plus, oops, my bad. 6 times 3 is 18 over 13 is equal to 2. So 8 plus 18 is 26 over 13. And 26 over 13 does, in fact, give us 2. So if if a homework asks you to check, that's exactly what I want to see for the check. Fractions should not be scaring you at this point in your math career. And if they are, please come in and get some help because I would love to help you with that. All right. So again, you have seen these types of solving equations back in Algebra 1, Algebra 2, all that wonderful stuff, right? Now look at example number 10, right? This will be our last example. So notice that you have a denominator that has a variable in it, right? So this takes us back to chapter 1, right? You're kind of figuring out what x cannot be, so our domain. So if you set x minus 2 equal to 0 and you solved, you would get x is equal to 2. So what can x not be? X cannot be equal to 2, right? Because you're going to get a 1 over 0, does not exist. All right, take a look at this example. So if I set x plus 2 equal to 0, solve for it, right? I'm also going to get x cannot equal negative 2, right? It'll work here, which will be fine, but it won't work here. And then last but not least, if I set the x squared minus 4 equal to 0, you're going to get both the 2 and the negative 2. So that's perfect. You don't have to do any work. If this was different, then obviously we would want to do a little bit more work. And I like to figure out what x cannot be at the very beginning, so that way I don't have to worry about triple checking my check, essentially. Okay, so the first thing I would want to do is I want to just double check what x squared minus 4 is, right? So that just becomes x plus 2 and x minus 2. So I notice it has both of the same binomials that the other two fractions have. So, excuse me, when I want to clear the denominator, right, I'm going to multiply both the numerator and denominator by the x plus 2 and the x minus 2. So basically, I'm going to multiply both sides by the x squared minus 4. So x squared minus 4. So my first fraction will become x minus 2, x plus 2, right, all over x minus 2. Over here, x plus 2, x minus 2, all over x plus 2. Oop, yeah, just x plus 2. And then minus 6x, x plus 2, x minus 2, all over x plus 2, x minus 2. So I'm writing it all out so that way you guys can see exactly what I'm doing. The x minus 2's over here cancel out. The x plus 2's cancel out. So notice that I'm canceling out the entire binomial with the that's both in the numerator and denominator. X plus 2, x plus 2, x minus 2, x minus 2. Yay! So all we have left on this side is an x plus 2. And then on this side we have a 3, and it's being multiplied by x minus 2. And then we have a minus 6x. And look how easy this problem becomes just by multiplying by your lowest common denominator. All right, so x plus 2 is equal to 3x minus 6, and then minus 6x. Do not distribute that 3 to there. Don't do that. Right? Collect like terms. X plus 2 is equal to what? Negative 6 minus 3x. Add 3x. Subtract 2. So 4x is equal to what? Negative 8. Divided by 4, x is equal to negative 2. Now, think back when we talked about negative 2. Can x equal negative 2? No, because notice that we wrote a restrictions. What can x not be? Negative 2. So this is a solution, but since it doesn't work because it's a restriction, no a solution. Right? That would be our answer. And we can see it in our, I broke my lead again. Okay, so we can see it in our check, right? It'll be 1 over negative 2 minus 2 is equal to 3 all over negative 2 plus 2 minus 6 times negative 2, negative 2 squared minus 4. So this will leave you with 1 over negative 4, and then this will be 3 over 0, and then minus negative 12 all over 4 minus 4, which again gives you 0. So let me write that out for you so you can see that. I'm just going to turn two negatives into a positive, so 12 over 0. So there's no way to put that into our calculator, right? 0 in our denominator does not exist, right? It's undefined. We get an error. So that is why our problem has a no solution. So you want to make sure that when you do some of those homework problems tonight that are from this section, this is from the appendix B3, please make sure that you do check any of your answers. Okay? As always, if you have any questions or comments, feel free to email me and I will get back to you as soon as possible. And I will see all of you guys on Tuesday.